This conference will now be recorded.
Okay, just a quick check. Can you all hear me fine and see my screen?
Yeah,
Okay, thank you. Okay, I think we'll get started. Okay, good evening, everyone, and thank you for joining on a weekend, that too at 9 p.m. All right, so hope you all are able to hear me and see my screen. Um, hi, my name is Kiran, and I have about 13 years of experience in information technology field. So I have worked on both on-prem and and also public cloud at multiple organizations. I would say I have some expertise in container orchestration and cloud, which is Kubernetes and Azure. So I'm a certified Azure solutions architect and also a certified Kubernetes administrator. I have taken up more than 25 training batches so far in the span of like last 4 years. Okay. Um, so that's about me. And as a matter of fact, I worked on both Azure and AWS and a little bit of Google Cloud and DigitalOcean. So yeah, I have a good amount of exposure to cloud, I would say. So okay, before we proceed, some ground rules. Obviously, be on mute if you do not have any questions. And we have a Q&A at the end of the session. But if you have any questions, you can ask me. I mean, yeah, don't just ask me in the middle of my sentence, but if I give a pause, you may ask your questions. Okay. And unfortunately, I cannot see why if you have put any questions in the chat, I'll not be able to see. So you'll have to unmute and speak. Yeah, because sharing on a double screen is a problem with GoToMeeting. Um, so I would expect, I mean, yeah, please feel free to ask your questions whenever you want to ask. And if someone is speaking, respect them and wait for your turn. That's it. So let's get started with the demo. So primarily what we are going to do in the demo is to give a bit of introduction about what is cloud and what is DevOps. And then you know, we will discuss about what is actually being taught in the course, what we are going to learn throughout this course. Okay, and also I will answer some like generic questions like how long is the duration, and what do we need to know, and all this stuff. Yes, we have it towards the end of the session. But if you have any other questions to the topics I discuss, please feel free to stop me and ask a question. That's fine. Okay, shall we get started?
Yeah, sure. Kiran, this is Chandra
Yeah.
here. Before you
Yeah.
get started, I just have a couple of questions, okay?
Yes.
So, before going to start, like what is on-prem and what is cloud, could you please explain what are the topics that you're going to cover in the training sessions, and what are the topics like your focus on for this
Okay.
training?
You want them right now?
Anytime is fine. Like the full course, like the
Yeah.
course, whatever the concepts that you're going to cover in the full course. Yeah.
Okay. Yeah. Apart from Azure, and I do also have a PDF of each topic that we are going to discuss through the course. But of
Hmm.
course, apart from Azure Cloud, just to satisfy your curiosity, we are going to go through these topics. Okay. And
Okay,
I will
cool.
explain. I'll definitely explain where they each of these things fit in as a part of your DevOps tool chain. Okay.
Okay, sounds
All
good.
right.
Thank you.
Yeah. So Linux, Terraform, Git, GitHub Actions, Docker, and Kubernetes. All right. Okay. Let's get started. So again,
Mm-hmm.
that's about me. If you have any questions about me, yes, go on. Otherwise, we can go ahead. Yeah, I would not say I have 13 years of experience in DevOps because DevOps wasn't that mature. It was there about like 8 years. So I have about 8 to 9 years of experience in DevOps. Before that, it was called with different names, system administrator and all that stuff. Anyway, okay. Um, Okay, let's get started. So again, like I told, what do we get to learn in this course, right? We understand concepts of software development lifecycle and IT operations and how they both interact. What is software development lifecycle? I'll come to that in a minute. And we will obviously dive into Azure Cloud and do hands-on Azure Cloud. We set up our accounts, we create resources there, we create VMs, we create Kubernetes machines, okay? Sorry, Kubernetes clusters, and we create storage accounts and all that stuff. So obviously, we are going to learn uh, some of the DevOps tools by doing, of course, okay? So I mean, by doing, I mean um,
Hi,
my
Kiran.
classes are hi.
Myself, Ramesh.
Yeah,
Just have only one question.
yeah.
Is it DevOps or is it Azure DevOps training?
Okay, it's not Azure DevOps platform training. It's DevOps tools plus Azure. Okay, so I will come to that point because others might not be aware about the difference between Azure and Azure DevOps. Okay, I'll come
Yep.
to that in a
Yep.
minute during the course of my presentation. Okay, but that's a good question. Yeah, I have that in my mind. I will answer that question. That's why I put this course name as DevOps with Azure. Okay, so it's not about a
Okay.
single tool. We are learning multiple DevOps tools. Okay.
Okay.
Um, yeah, I mean, I would say multiple technologies that are important for a um, DevOps for someone to get into the role of DevOps engineer. Okay,
Okay.
right. So we are going to learn about Linux, Terraform, Git, GitHub Actions, Docker, Kubernetes. Okay, if all these sound very new to you, don't worry. I'm going to explain. I mean, you might have heard about them. That's why you are in this training, in this demo. But I will also explain what each of these mean. Okay. Okay, so first we will start with the concepts of cloud and then we will go to the other topics. All right, but even before we start with the cloud part, right, let's understand how applications work in real world. Like how is the IT working in real world, right? For example, we all are, when I say we, every one of us in this demo, our parents are also dependent on technology today. Every one of us is using technology, right? It could be YouTube, it could be WhatsApp, okay, it could be Paytm, Phone Pay, Google Pay, you name it, right? So um, so everyone is technology dependent, but we also need to understand how does this technology run, right? What's happening when I'm talking here, and how are you all able to listen to me, right? So is it directly, am I directly talking to you like a landline connection or something? No, right? So there are intermediaries between you and me. Like I'm sitting here in some place, okay, and let's say Ramesh is sitting in some other place, connected to his network. I'm connected to my network, okay, but I'm not directly talking to his router, right? I speak, I whatever I speak goes to the GoToMeeting servers, and Ramesh is also connected to that GoToMeetings. And whatever I speak here is processed here and sent to Ramesh plus several others who join in this course, right? I mean, all of us who join in the course. So what's happening here is the voice is converted into digital form and all that. We'll not go into that. But what do I mean by servers, right? Nothing but computers that are designed to do a specific task. Okay. So for example, when we open the GoToMeeting page, you see the interface like this. This is a web page, but in the background, there might be another server which is processing my, voice and converting into digital format and sending broadcasting to all of you. Okay. So these are at the outside nothing but servers, physical machines. Okay, not only GoToMeeting, you can take any application, HDFC net banking application, or let's say Google Pay, or in fact Google Pay has multiple layers, right? Because your request goes to Google and Google will send it to the banking servers, and the banking servers will send the response to Google, and again Google will send the response to you. There are multiple layers. Okay, so what happens is there are clients and there are servers. Client is nothing but the person who is requesting the information. Server is the machine which is answering your request. Okay, so once we understand this client server architecture, then we can go further. Okay, so what I mean by that is there is always someone making a request to a computer, and the computer is sending the response back. Okay, so this could be of two types. One, people making a request to a server like we do on a browser. When we go to google.com, our browser is the client and we are making request to the Google server, right? There could be other cases where systems are making calls to other systems. For example, the best example is UPI payment. Let's say I'm using Google Pay. My request first goes to the Google server, but Google doesn't have my money. HDFC has my money, for example. Okay, so the request is forwarded to HDFC bank servers. So here, this person is the client to this server. This is not even a person. This is a computer, right? So there are a lot of intermediary devices also. Intermediary devices means I will not directly send a request to a server which is sitting in Google data centers. I might be sending it to a load balancer, right? Load balancer is also like a router, but its work is to distribute load across different servers. Okay, so the basic thing is if you have to create any kind of online service. Okay, it could be a online commerce platform like Amazon.com or Flipkart.com, or a payment gateway like Paytm or PhonePe or GPay. Doesn't matter. Everything should have a place to put their servers, and also have other networking devices like routers, gateways, firewalls. Okay, these are all different kinds of different kinds of devices, like every organization has to manage in order to provide services to people. Okay, so traditionally in the old world, what used to happen is, let's say I have an idea. I am a developer. I want to create an application and make it available to others. Okay, so first what I do, um, I will create a website on my laptop using whatever coding I know, whatever language I know, let's say in Java, and I show it to my friends, but that is only living on my laptop. If I have to make it available to others, I have to first, okay, buy a server. Okay, buy a server and log into this server with whatever. I mean, you can connect this to a monitor, you can install your software, operating system, everything. I mean, operating system on top of it, software, and then put on your code and make it available to the public. With one server also, you can make it available to the public. Of course, you need other things also. You have to buy your domain name, right? Like your website name. Let's say you want to create a let's say I want to create a website like devopsgym.com, right? I want to create a website called devopsgym.com where I do my trainings. So I have to buy this domain name from someone else. So what I do is I give my IP address and say whoever is trying to reach to devopsgym.com should go to this IP address. Okay, what is an IP address? If you don't understand, that's fine. A computer has an address. I give my computer's address to this domain name. Okay, this is fine. So your website is working and you're getting more and more people. Uh, more and more people are logging into your website. That means your server might not be able to handle all the load now, right? So you need more servers. So you buy one more server, and whatever you did, like installing software, operating system, installing software, installing your code, everything you do on the second machine as well. But you have to distribute the load among these two systems. You cannot simply have two systems and expect the traffic to automatically move between these two things. That's when you need a load balancer, right? So you will buy this device called as load balancer. Okay, it is like your router. Okay, then let's say the traffic even increases from two servers, you have to increase to four servers. Okay, now you want to make your application more mature and you think, okay, I want to run my front end part, which is the web page HTML side, on some servers, and the back end part where is the business logic is applying into different set of servers. And maybe you're hiring more people also, then you want to do the database in a different layer. Okay, that is very commonly done anyway. So this is your web tier, this is your business logic or app tier, and this is your database. Okay, and again between these layers you will need load balancers, because computer can reach to other service using IP address, but if you have four IP addresses it doesn't know where to reach, so you need a load balancer. All right, so if your business is growing, you might increase these number of servers, so you have to create a dedicated room for this and put on. And remember, these servers are those which are running 24/7, right? 24/7, 365 days, they have to keep running. That means they generate a lot of heat. So you need cooling solution now. Okay. So you buy coolers now, coolants, right? I don't know if we have anything for that. But anyway, so you put them in a place called, which is generally called as a data center when you have a lot. Okay, so a data center is a place where you put all your servers and everything. And of course, you have your routers. Now, more cables are there, and you have to buy more disks to store more data. So it goes on and goes on and on. Okay, but let's say after investing so much money, okay, suddenly one day there is a big competitor from Udemy or something who has kind of taken away your traffic. They used some aggressive marketing tactics. You are a startup, you don't have much money to, you know, of course, you need firewalls and stuff like that also. Okay. So you will need a lot of devices. You invested a lot. After going well for 6 months or 7 months or 1 year, your traffic has decreased. Traffic and there are no one coming. You try to sell it to some other company like Udemy or Udacity or whatever companies, but no one is really willing to say, because you don't have any specific IP, so no one is going to buy. So what happens now? Okay, I invested a lot. I also bought a room or I created my own data center. This is your what we call as a data center. Okay, where you have your resources related to networking, storage, and compute. Compute means the servers. Okay, so a data center is a place where you host all these resources, right? So in the traditional world, everyone had a data center, but those were companies which already had offline business. For example, take banks, right? So banks have been running from more than maybe 300 years. Okay, some banks have been running from 150 years, 175 years. So those banks slowly digitalized and moved into on-premise. Of course, there were some technology companies like Google and Microsoft who again built their own data centers to maintain their, applications and everything. But think about it, like for a startup like Flipkart, for instance, when those guys wanted to start in 2007 or 8, I don't know when they start, or 2010 maybe, when they wanted to start Flipkart, if they have to invest a lot of money with uncertainty meaning they don't know if their product is going to be a hit or a miss, right? So without knowing this, they have to rent a place, they have to buy the service, they have to put the cooling, and they also have to put physical security outside. Correct? Right? If you have a data center or any building, you have to put security, right? So you have to invest a lot of money and of course some engineers to manage these servers. And of course you have your development team, which is actually developing your application. Okay, but maybe the development team are the founders themselves, but still you would have to invest a lot of this money. But enter 2006, when AWS has actually started a public cloud, they said, "Hey, you have an idea to start a business online, or you have a beautiful, innovative idea with which you want to start an online service like a Flipkart.com or a Ola or a Uber. Okay, don't worry, you don't have to invest anything. You can come to us. We have already created lots of infrastructure around the globe. Okay, you can simply rent our resources without paying us anything in advance. Okay, so let's say the same situation now. These folks from Flipkart, they had an idea that, okay, we can maybe create an Indian alternative to Amazon.com and we start our business online. It's a e-retail business. Okay, so then where do they host the application, right? They went to AWS and said, hey, AWS, we want to, I mean, you don't have to even talk to anyone, right? You can just log into aws.com, aws.amazon.com, and create your account and create your own servers after entering your credit card details. Okay, you don't have to pay even a single rupee at the beginning. You can start using their servers, install your application, let the other users access the application. Okay, all that they need to do is buy the domain name called as flipkart.com. Okay, and go to amazon.com, create some VMs, virtual machines, okay, or servers, however you want to call them, and install their software which they have already developed and make it available to the public by creating a DNS record, right? So now flipkart.com is a positive case, it's a hit case. So they needed more servers, but Amazon is saying that ours is like a Akshaya Patra. No matter how much you need, you will keep on getting your new resources. Okay, for example, let's say Flipkart started their initial business with um, let's say oops, three web servers. Okay, I mean web servers are nothing special, but just some VMs where web service is running, and let's say three uh, you know application servers and three database servers. Maybe they have some caching servers to speed up their application. Maybe they started with 12, but eventually they needed more and more. Maybe they have grown up to 16. Okay. So the beauty of cloud is you don't have to pay anything in the initial phase. After 1 month, you can pay your bill. And let's suppose for whatever reasons, Flipkart has failed, then they can simply delete all these machines and forget about it and only pay for that 1 month or 2 months, and they don't have this much investment. These might cost you like thousands of dollars, right? And these are like long term investment. You cannot easily dispose them. You have to sell it on the second hand market. You might or might not get the returns on it. So it's a pain. Whereas here you just pay for the 1 month bill, which could be like 500 euro, $500 or $600, and forget about that. Okay. So now coming back to the textbook definition of cloud. What is cloud? So cloud computing is the on-demand availability of computing resources without the direct active management by the user. What does it mean? Okay, again, I will give you a real life example. Okay, so let's say before the Ola and Uber time, if you have to book a cab, okay, let's say tomorrow morning at 8 a.m. IST, you have to go to the airport. Your flight is, let's say, at 11 o'clock. So you call, there is no Ola, there is no Uber. What do? You actually pick up a phone and call Sky Cabs or Dot Cabs or Z Cabs and say, hey, tomorrow I need a cab at 7:45. Okay, because Hyderabad punctuality. Let's say you're living in Hyderabad. So if you say 7:45, he might as well come by 8:15. And you say, hey, I need a cab by 7:45 a.m. tomorrow morning. So the Dot Cabs guy will say, no, we have one at either 6:30 or the next one is at 9 o'clock. Then you say, okay, let me try something else. Okay, maybe he call you call zcabs. Okay, that is your direct active management. You are doing the direct active management yourself. Okay, uh, but think about today's, right? You just open the app 10 minutes before you want your cab and book it, and your cab arrives. Okay, if you're lucky. Otherwise, sometimes you have to try multiple times. Anyway, so this is what we call as on-demand availability. If you need some resources, just log into Azure portal or AWS portal and create your resources. Okay, without the direct active management by the user, meaning you don't have to manage everything all the time. See, when you're booking a Ola cab, you just wait for the cab, go and sit inside the cab. You don't have to, you know, manage that cab by yourself. You're just renting it for that much time. Similarly, when you're hiring virtual machines, okay, that means virtual machines are created from physical machines. Physical machines means actual servers. They look like this. If you want to, you know, Dell Edge servers, if you want to have a look at how the physical servers look, this is how it looks like, your old school CPU type things. Okay, but what happens is these are needed in tens and hundreds, okay, based on the size of your company. So these are maintained by companies like Google, Microsoft, and Azure in today's Microsoft and AWS or Amazon in today's world. You don't have to worry about maintaining all these servers. Okay, this is what a traditional, I mean, any kind of data center looks like. These are all single physical servers. Okay, from each single, I mean, from each physical server, you can create multiple virtual machines. That's a different matter. We can talk about that in our virtualization class. Okay, so you don't have to invest in all that area. You don't have to buy that physical server. Okay, you just log into AWS and click on some things, and your servers are ready. So that's what on-demand availability means. And without the active direct active management by the user, meaning you don't manage the servers, someone else is managing for you. Okay, but at the core of it, okay, at the core of it, cloud is nothing but, I mean, as opposed to the name, cloud means on the sky, right? But as opposed to the name, cloud is nothing but a collection of data centers managed by a cloud provider. Okay, meaning, so when Amazon wanted to enter into this business, what they did was they created multiple data centers across the globe. Okay, they bought hundreds of servers, thousands of servers, and they created data centers like this. Okay, this is one of the real-time picture of data center. Okay, from the top you can also see some images. Okay, so these like this, for example, this might be from one of the location in the US. Of course, you know, right now we also have an AWS region in Hyderabad. Azure also has one region, I guess. Okay, so these are the data centers. This is where your servers are all hosted. Okay, of course, you as an end user, when I say you, it's not only you and me, even our organizations which are using Azure, they don't need to know exact physical location of all the servers. We just need to know that we are using of a particular region. It could be, you know, US East 1, US East 2, or US West, or whatever region. You don't need to know the exact location. You don't need to know how the data centers are managed. They are all managed by AWS for us, or Azure for us. Okay, you just create a connection and start using it. Start using some of the servers. Okay, so that's why what I mean is cloud is nothing but a collection of data centers across the globe. Okay, so for example, Azure has about how many? I think 50 or 54 regions or something like that. Okay, that means in 54 regions they have set up their data centers in multiple places. Okay, and you can connect to them from anywhere in the world. Okay, of course, you want to create your infrastructure in an area close to the nearest data center. That's a different matter. But Azure has already set up these data centers available for everyone. Of course, you can use them on a pay as you go model. What is that model? Pay as you go. What does that mean? Just like your Ola or Uber, if you're using it for 10 days, if you're using it for 10 minutes, you pay only for the 10 minutes plus GST plus all that stuff. Okay, similarly, when you're using a VM, you, let's say you created one VM to test something on cloud, and you used it for 1 day 15 minutes, you will pay exactly for 1 day 15 minutes. Okay, similarly, you create a storage disk and you use, let's say, 100 GB storage disk, and you pay only for the 100 GB storage disk. Okay, So a real life example is, again, I told you already, if there is someone who is willing to invest in start a new business, he can simply start it. Okay, and there are other characteristics of cloud. I don't know if I have covered here. Okay, so yeah, these are the characteristics of cloud. So when you say cloud computing, what does that mean? Okay, that means on-demand self-service, and these are, by the way, standards set by NIST, National Institute of Standards in Technology, I guess. It's a US institution. So they said if you want to call some service as a cloud computing, they have to meet these five characteristics. On demand self service, meaning you don't have to send an email to someone or call someone to set up your VMs. That was the old school. All that you need to do is log into your portal and create your resources. That is the self service, or use some programming language. For example, we are going to do that using Terraform. We're going to create resources on Azure through Terraform. Okay, broad network access. So you should be able to access these servers services from laptop, desktop, mobile apps, and also through various mechanisms like, you know, cloud, command line and other stuff. Resource pooling. Okay, basically resource pooling means, just take the example of Ola and Uber, right? So when you make a request at 10 a.m. and a Uber comes to your place, a particular taxi from Uber comes to your place, 10 to 10:30, you are the owner of that taxi, of that service, and you use it. From 10:30, you get down, and let's say 10:45, someone else is using that. That is what we call resource pooling, right? So you have a bunch of resources which could be accessed by different people. For example, let's say you created 10 VMs today and started using and applying your application, but tomorrow you reduce the number to 15 VMs. That means on the physical server there is some capacity left that will be used by someone else. So you have a bunch of resources which are pooled together and anyone can use from it. Okay, the next one is rapid elasticity. Again, think about the big billion sale that Flipkart conducts every once in a year. I think now we had Amazon Prime Days, and August 15th, they'll all start some kind of, sales, which is again cheating. Anyway, so on these big billion sales or whatever the sales they call it, you know, they know that your traffic will be multiplied by 2 or 3 times. Meaning, if regularly at any given point in time, 1,000 users are accessing Flipkart at a single point in time, not in the entire day. That's what we call as concurrent users. So let's say that might go up to 3,000. Just giving an example. My numbers are like made up. Okay, so regularly you have 1,000 users at any time logging into your systems. But on Big Billion Sale, let's say the number is increasing by 3 times. 3,000 people are logging. So that means your resources should also increase by 3 times, meaning you should need to have three more server. For everything into three. Okay, if you have 100 servers, you have to make them 300 servers. If you are doing it on the old school on-premise environment, on-premise means you maintaining your own servers, you have to plan very well in advance. You have to book those servers. You have to call Dell or HP and ask them to, send the servers to your location. And suppose there was a natural calamity and the servers could not come in time, you can never rely. But when it comes to cloud, you can scale very rapidly. From 10 machines to 200 machines, you can go in a matter of a few minutes. Okay, that is rapid elasticity. Not only going upwards, meaning increasing the number of servers you are using, but you can also decrease the number of servers in a quick time. That is elasticity. Measured service. What does measured service means? So measured service means, imagine if we have our electric bill in such a way that every month you get a bill stating that for your fan, we you have used so much of fan, that's why we charged you 1,000 rupees for fan. Your AC, you have used this many watts, so we've charged 3,000 rupees for that. If you get that bill, that would be awesome, right? Of course, for electricity board we cannot get it, but for cloud we can get it. Okay, it will give you a detailed billing of how much money you spent on what resource. Like, is it on storage like disks, or is it like load balancers, or is it like your VMs? Where did you spend the money? It gives you detail by detail. Okay, just like your postpaid mobile bill, where you get, like, for so many SMS you spent this much, you made these many calls, so this much amount. Like that, it gives you a measured service. Okay, that's what we call it as measured service. So these are the 5 characteristics of cloud computing. Okay, on demand, self-service, broad network access, resource pooling, rapid elasticity, measured service. And the advantages are these. Okay, um, what are the advantages, right? So you have pay as you go. Pay as you go means you, oh, sorry, even before that, no upfront cost, meaning you don't have to pay anything in the beginning, only at the end of the month you pay. Pay as you go. You will pay only for the amount of resources you're using. You don't have to do like, okay, see, think about again the old school taxi booking, right? First you have to say, from here to here, if you don't know the distance, he might like loot you saying that we'll charge you 200. But now with Ola, Uber, they have, I mean, if they're not doing anything shady, you know how much you're paying for the distance, right? Okay, pay as you go. And again, elasticity is another feature. Auto scaling, some of the, I mean, one of the greatest feature is auto scaling, meaning it's dynamically your servers are increasing and decreasing based on the number of users accessing your systems. Okay, this is another great example, auto scaling. Okay, so these are some of the advantages of cloud. Okay, any questions now? Okay, in 2 words, if I have to say what cloud is using someone else's servers and disks and storage and networks to run your own applications, and you pay for the amount of resources you're using. You don't have to build your own data center. Okay, data center is typically the place where your servers, your routers, your network devices like load balancers and storage devices are stored. It is taken care by someone else. You simply, you know, use their services and start using it. Okay, any questions? Okay, let's go to Microsoft Azure. What does Microsoft Azure what is Microsoft Azure, right? You might have heard about this name. Okay, Azure is one of the 3 and fastest growing cloud providers. Okay, we have AWS, Amazon Web Services, leading the pack. This has been there from 2006, so it has its early bird advantage. Azure has started around in 2010, so it's slightly backing. But Azure, you know, Microsoft is aggressive in marketing. They give you all kinds of discounts to big organizations and all. So Azure is also spreading rapidly, and also they have their services which are being used from 2 or 3 decades, like Active Directory and other services. So Azure has an advantage there, right? Whereas AWS, it reached a saturation level in the sense the number of new customers coming to AWS is less as compared to Microsoft Azure. Okay. Anyway, and the third one is Google, which is again in terms of market share, I think Google is somewhere very below Microsoft. Then you have other services like, let's say, IBM Cloud, Oracle Cloud, um, Alibaba Cloud, DigitalOcean. There are many other clouds, but you know these three are the biggest. Azure. Uh, what is the other one I said? AWS, obviously AWS, Azure, and Google Cloud. Okay. Okay, so I did not create any slides about Microsoft Azure as such because we are going to discuss that in our initial classes, right? Okay, so if you look at Microsoft's global infrastructure, right? Not Microsoft, Azure global infrastructure. So Azure has about 60 regions, okay, and different data centers. Like these are the data centers like Azure has in globally. Okay, we have one in Hyderabad also. Microsoft in Hyderabad, I don't know, is it in Chennai or Hyderabad? I don't know, but there is a South Indian region. I know that much. Okay, so if you see what this means is like across the globe, Microsoft has. I think I can show this interactive map, which they copied from AWS. Okay, across the globe, Azure has their data centers located in at least 60 different regions, and They are connected through Microsoft Network. And let's say if you have to start a business in Australia, of course, you can create your servers there. I mean, you don't create, you make a request on Azure and Azure will create for you and you can start using them. Okay, so you can see these are various kinds of services Azure has across the globe. Okay, this is the North American continent. And what are these blue ones? Okay, so these are geographies or regions. Then you have regions and then edge zones. I will talk about edge zones little later. Okay, POP, point of presence. Okay, so they are also giving their sustainability, like what they are using for the energy. For example, if you look at some of the US, for the power, electricity, they are using wind. Okay, windmills and stuff like that. So because today everyone is trying to be carbon neutral. Okay, this is in Europe, and you can see this is India, and obviously I think it's South India. It looks like more of Chennai. I don't know where it is. Okay, there is one in Mumbai also, Central India, and you can see there are some in Australia, some in Chinese region. Okay, so basically you can see their businesses are mostly, I mean, their data centers are concentrated in the US, unsurprisingly, and also in the Europe. Okay, uh, so that's how their data centers are spread across all of these. Okay, so what does this mean? Let's say you're working for a US company from India, so you don't have to actually, yeah, your client will still create their requests. I mean, not your client, sorry, your employer, your organization will still create their resources in, um, let's say, US. You can manage from India itself. Okay, sitting in India, I can create any resources anywhere in the world. That's not a big problem. Okay. All right, so that's about Azure Global Infrastructure. We will dive deep into what is a data center, what is a region, what is an availability zone later. Okay, but that's about Azure. Okay, any questions? And like I told you, Azure is, okay, someone unmuted. Any question?
Hi sir, can you please explain the difference between the Azure technologies? Azure is a web application server or not?
See, Azure is, can you mute? I can hear my own voice.
Yeah, yeah.
Azure is not a web application service or a application server or a database. It is your core infrastructure. Okay, you can build whatever you want to. Let's say, you go to a mall and you can hire a place of 1,000 square yards. What do you want to do in the 1,000 square yards is up to you. Maybe you can put a food stall. Maybe you can put a, let's say, food stall is like a web server, or maybe you want to put an entertainment gaming zone. Okay, or maybe you want to put a a retail apparel shop like Nike shop or whatever, or multi-brand store. Whatever you want to do is up to you. So the mall, the shopping mall is only giving you that area of 1,000 square feet, and you agree to pay a certain amount, right? So similarly, Microsoft Azure will give you different kinds of services. You can use them like servers, like disks. If you want to run web servers, yes, you can run web servers. If you want to run Java applications, yes, you can run Java applications. You want to run PHP applications, yes. You want to run Python, yes. It's all up to you. Okay. It's not like the programming language specific or anything. You can run anything on Azure servers as much as you want. Okay, it's infrastructure. Instead of building your servers, you're renting the servers from Microsoft Azure. That's it. Okay.
Thank you sir.
Yeah, no problem. Okay, let's go forward if you don't have any other questions. Okay, now we'll talk about DevOps. Okay, so what is DevOps? Like everyone is talking about this DevOps, but what is this DevOps, right? So think about this. In the good old days, what would happen is there are a bunch of set of developers. Like when I say old days, like at least 15 years ago. Okay, so let's say he's dev 1, dev 2, so on and so forth. Okay, so they're they're writing the code, and you know Come on. Let's say so many developers, and they all write the code and put it in a centralized location. Okay. Let's say something like GitHub, because when multiple people are working, they cannot keep their code on their own laptop for a long time. Okay, initially they write it on their own laptop, but eventually they'll push the code to a GitHub repository. Okay, then what happens? There is another set of team called as operations team. Okay, ops engineer or server administrator or whatever you want to call. These people, what they do is, you know, they create your servers, or they manage them. At least if there might be someone else who is creating for them, they will manage these VMs, like installing the required softwares, okay, running operating system updates, giving access to anyone if they require access, okay, doing the monthly patching, restarting whenever required, and doing all the administrative stuff. Okay. So then they also have to take this code, okay, in the repository and put it in the servers. That's one important part. Right? Code is nothing but bunch of files, nothing else. Bunch of files where you have different kind of text. Okay. But sometimes you cannot directly put this code into the servers. For example, if you're running a Java application, for instance, a Java application has to be compiled. Compiled meaning it has to be converted into a single file. Like in Windows, if you want to install an application, you install .exe file, right? Right? Download a .exe or .msi files and install. Correct? Did you ever install any software on your Windows laptops?
Yes.
No one. Yeah. So you download a .exe or something, right? So the .exe is what we call as the binary format. Okay. Meaning before it was into .exe, it is also a bunch of files, but it was compiled together into a file. Okay. So what happens is there is a process where you take this code, and this process is called as build process. Okay. You take this code from here and put it in a build server. Okay. And do the compilation, and from this comes a binary file or an artifact, whatever you want to call. Okay. Artifact, and this artifact has to be deployed onto the servers, and your application will then start running. Okay. Of course, before this artifact is installed, these servers need to have the required software to run this artifact. Okay. For example, if you have built an application in Java, your developers have coded this in Java, they submitted in the repository, then you take it and use some third party tool like Maven. Okay. Or I would not say third party tool, a Java build tool like Maven, and using Maven tool, this entire code is converted into a single file. For example, in Java, you have something like my app is the name, for example, and .var is the format. So you create a .var file, single file. All this code, it might be like 10 and 15 or 20 different files, but all of this will be compiled into a single binary file called as var file. It is called binary because you cannot see it. It is written in the form of ones and zeros. Okay, then you take this WAR file and deploy in the servers. But before you deploy this WAR file in the servers, you have to make sure these servers are running some kind of a Java runtime, okay, or a Java development kit, which can execute this file. Okay, so that is all done by the ops engineers. Okay, they are responsible for this part, right? But what would happen is there is always a kind of a wall between these two teams. When I say wall, not a literal wall, but they never know what was happening in the development side. Okay, maybe the developers are developing the code for 50 days, 40 days, and suddenly one day some ticket comes to ops engineer, or a email comes to an ops team saying that, hey, we have built an application. Now convert this into whatever format you do, and deploying the applications. Then there comes an error, and this ops engineer says, "This is not working." He goes back to the developer or development lead, and the lead says, "No, it is working on our laptops, so it's your fault. You fix it." Why? What might have happened? It could be different reasons. Maybe they are using different versions of Java on their laptops, and there is a different version of Java on the development systems. Okay, or there might be some conflicts when multiple code is merged at the last minute. Okay, so there are different kinds of issues coming out of this because these people are always in the blind side. They don't know what's happening on the development side. Okay, and also there is no a sense of automation across the teams, so everything is happening manually. Okay, so then came the development practice called as extreme programming. I'm talking about early 2000s. Okay, so then came the process called as CI/CD. Okay, then came the process. From this we have DevOps. Okay, which again also coincided with the time Agile is growing across the globe. Okay, what this DevOps team says is that, hey, remove these barriers. Okay, now Dev team and Ops team will work together as one team. Okay, maybe Dev 1 and Dev 2 are working on some set of features, but also along with them take one ops engineer. You'll all work as a team. So you'll all discuss what is happening in your project from day one. Okay. So you'll also share any kind of blockers that you have. So from the first day itself, the ops engineer knows what kind of project they are preparing. So he can be prepared with what kind of servers he have to prepare, what are the dependencies and stuff like that. Okay. So this is basically DevOps means bringing the development and operations team together. What is the idea behind doing that? What is the main purpose? When what is the reason to break these barriers and make these people sit together? The ultimate goal of the business is to bring more changes to the public. Changes in the sense new features in your application to the public. What do I mean by that? Okay, think about WhatsApp, right? So when WhatsApp started, maybe in 2011 or 2010, right? There were not many features. It was only meant to be a text messaging tool, but which is happening on the internet. In other words, it was a little bit better version of Google Talk we had at that time. At that time, Yahoo Messenger was not very popular on mobile. Only Google Talk G Talk was very popular. Okay, if you're old enough like me, you know that. And then, but Google Talk is not able to handle messages when there is no internet. Okay, so WhatsApp is also able to handle the offline messages, meaning you can still see your messages even if there is no internet. Then it came with new features. Next, it introduced images, emojis, then GIFs, then images, then calling, then status, then video calling, then groups. So it iterated. So when WhatsApp started, it did not start with a big, you know, it did not bring everything at once. It started with its only simple text messaging platform. On top of it, it added more and more features. Even today, it keeps on adding more features, right? It added like very recently, you can think about swipe to reply. You can swipe on a message and reply. I mean, it's not very recent, like almost 2 years, I think, but so an application continuously iterates, and now it's trying to bring in business customers. So it's trying to uh, introduce payments through WhatsApp, whatnot. A lot of things are happening. Okay, so this is what we call as a continuous improvement of your application, right? So for that to, if WhatsApp has to stay on top of the business, it has to do it on a faster scale. Okay, that means you need to have better synergy between development team and operations team. Okay, so they should work as a single team, understanding the objective of the business. The objective of the business is obviously bringing in new features based on the market research. So WhatsApp has some business development team who will understand its customers and give suggestions to the technology team what to do. Okay, technology team implements them. So this is also what Agile tells you. Agile tells you that don't launch a big bang application, but instead launch a product which works, which is called as MVP, minimum viable product, meaning it should do what it is supposed to do, basic things. It may not have all the fancy features, but as time goes on, keep on adding new features. Okay, then by doing this, you're already starting in the market early, and also you're delighting the customers by adding new features every now and then. right? That's how WhatsApp is able to retain everyone. Let's suppose WhatsApp did not launch on 2010, but it waited till 2016 to make sure all the features are there developed, like video calling and everything, and then launch the application. What would have happened if WhatsApp did not launch in 2010 but 2016? What would have happened? Someone like Telegram or Signal would have been the top messaging apps today. Globally, not only in India, globally, WhatsApp is the leader in text messaging, right? You know that, right? Even in the calling also. I think FaceTime is there, but FaceTime is only limited to Apple devices. WhatsApp is the top because it launched early and it keep on iterating. It kept on iterating. It added new features, right? So similarly, so that's what gave this thought of DevOps. DevOps is about bringing in this cultural change where development and operations team work together. But the important aspect is not only working together. To make things move faster, you have to automate. Let's say WhatsApp is saying that, hey, more and more users are coming. So today we have, let's say, 150 servers. We have to increase them to 250 servers. How do they do that? In a matter of few minutes or few days, right? So they need automation for that. Or let's say developers are developing every day. They're doing bug fixes, they're doing security fixes. So these things have to be quickly developed automatically and quickly tested automatically. And developers should immediately see the results if whatever changes they have made are working before they release to the end users. Okay, so or WhatsApp might be launching a additional feature or additional service which is not WhatsApp. It could be WhatsApp Business, WhatsApp for Business, okay, or WhatsApp Payments. They need additional servers for this. So and additional software configuration and everything. All these things have to happen really quick. Okay, that's why you need this DevOps culture. So basically, DevOps is more of a cultural thing rather than a technological shift. But of course, we'll talk about that in detail now. So basically, there is something called a software development life cycle. You create, you plan, okay, you release, you configure, you monitor. Okay, I mean, sorry, you create, you plan, you package, verify, then release, configure, and monitor. Monitor means you have to see if your application is working well or not. Okay, all these things you have to combine between dev and operations team working together as one team. Okay, so going by that strict textbook definition, this is what DevOps is. DevOps is a set of software development practices that combine software development and information technology operations, or simply IT operations ops, to shorten the system development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. So I will not take much time, but just take one example, right? Let's say WhatsApp business development team says, let's say I'm going back a little in time, let's say in 2017 or 2018, hey, know what? Everyone now wants to create their own groups. Let's say at the time groups was not there. They want to have a group chat so that they can talk to only I mean, they can talk together. Like once message is seen by everyone. So business development says that, okay, everyone is interested in doing this. Now, this has to be designed by your software architect. What needs to be changed in the system to bring in this feature? Then it has to be built or created. Someone has to create the code for that. Then it has to be tested and then released. Finally validate from the end users if everything is working fine. So this is the entire life cycle, system development lifecycle. This has to be shortened, meaning you don't skip the phases, but from here to here, it should not take days and weeks. It should happen I mean, it should not take at least weeks and months. It should happen in a few days. Okay, that is what shortening the development life cycle. But while doing this, you should not also compromise on quality. Quality should be maintained, right? That's what DevOps is all about. So DevOps, in strict terms, is um, not a new role like Java developer or a React developer. But what happens is in practice, there is a role called as DevOps. That's why Google says there's a book called as Site Reliability Engineering or SRE by Google. Google says DevOps is a culture that has to be followed by everyone in the organization. SRE is the team, okay, or SRE means again Site Reliability Engineering. This is again a Google concept, meaning everyone else is also using this concept. Site reliability engineering is the team which implements DevOps, right? But of course, we don't have everywhere site reliability engineering teams. We have teams called as DevOps teams. I'm working in one of the DevOps teams, right? Um, yeah. That's the idea. So DevOps aims to create better coordination between development, QA, and operations to speed up software release with utmost quality. The primary aim of adopting DevOps culture is to um, build and release software quickly and maintain applications with high availability and resilience. Not only building the applications. Let's say WhatsApp has so many features, but let's say every few hours WhatsApp is inaccessible, or it's giving some weird messages like cannot deliver messages, okay, or cannot see the status, whatever it is. Then it's no use. It should be highly available and resilient. Resilient means even if there is a failure, it has to recover faster. So DevOps is all about giving the developers that power to build software quickly and deploy quickly. Okay, so what does a DevOps engineer do? Own and manage IT infrastructure for an application or set of applications. Sometimes you might have a DevOps engineer dedicated to only one application or maybe multiple set of applications. Okay, so he's also responsible for maintaining infrastructure provisioning, configuration management, application deployment, like CI/CD, and monitoring. Monitoring sometimes could be taken care by other teams. And apart from all this, the core thing about a DevOps engineer is automation, automation, automation. Okay, so I will take 2 seconds to explain, then we'll go to the course curriculum. So there are different layers in an. If you start an application, it starts with your infrastructure, whether it's on cloud, on premise, doesn't matter. Infrastructure. So you have to build infrastructure for your applications to run. When I say infrastructure, I mean the servers, the network switches, routers, firewalls, all these things. Even disks also are part of infrastructure. Then on top of it, you have your operating system layer. Okay, like if you're running your VMs, you also maintain your operating system. On top of it, you need to have your configuration, software configuration. What do I mean by software configuration? Like I told you, if you have a Java application that has to be run on 10 servers, and all these 10 servers, you have to install Java development kit or JDK. Or if you want to maintain 15 database servers, you have to install MySQL software on these systems. Okay, if you want to run Apache web servers, you have to install Apache software on these servers. So that has to be also configured as per security practices. That is software configuration. Then you have your actual code. Okay, and this code, I told you, right? This is not like directly taking the code and putting in the servers. You have a process called as CI/CD that has to happen here, right? Your application. These are the various layers. So how do the DevOps teams manage all these things, right? So here, to maintain the DevOps infrastructure in an automated way, we have IAC tools or infrastructure as code tools. The prime example is Terraform, which is the like leading tool in the market. Everyone is using Terraform to create their infrastructure today, automatically create infrastructure. I mean, why do we use Terraform? I'll come to that later. But basically, instead of going to a Azure portal and clicking and clicking and clicking, you write some code and it creates the code. It creates the resources for you. When I say resources, those could be servers, disks, load balancers, Kubernetes clusters, anything. Okay. Then for OS management, of course, when you're running enterprise grade applications, okay, when you're running enterprise grade applications, you don't create um, you don't run mostly on Windows. You run them on Linux. Most of the servers, maybe we are talking today on GoToMeeting, sorry, GoToMeeting, but in the background GoToMeeting might be using some Linux servers to process my data and send it to you. Okay, so that's why we are going to learn Linux. Okay, because on the servers everything is managed through command line, not by graphical user interface or GUI. Okay, then software configuration. There are tools like Ansible. I'm not discussing in this course, but if time permits, I'll take one or two classes on Ansible also. And then for the application deployment, we're talking about CI/CD. I'll explain about CI/CD, and we'll use GitHub Actions for that. Okay, and all this time you're writing code in Linux, you're writing code for Terraform, you're writing code for Ansible, and all these things should be stored in somewhere. So that's why we are using GitHub to store our code. So we will learn about GitHub and also Git. Okay, Git and GitHub are two different entries. Don't be confused. Git is like a software, GitHub is a platform. Okay, I mean, don't worry about it if you don't understand. We can talk about that later. Okay, um, so we have all these things coming into part. And now we have containers. You might have heard about the term Docker a lot of times. What is Docker? Okay. Docker is also a way of deploying your application. So it's also part of this. So we're going to discuss Docker and Kubernetes as well. Okay, we're not discussing Ansible, but I'll try to squeeze in one class at least. Okay, then we have Git and of course, where do we do all this stuff? Because we don't have a lab, right? So we're doing all this thing. Our core infrastructure is, of course, some of the stuff we are doing on GitHub, which is again, uh, which is again free for us. Don't worry. Azure is also free for 1 month, but our classes will go for 2 months or sometimes more. Okay, then you might have to pay some money or create a second account. That's not a big challenge anyway. Where is the Azure logo? I don't have an Azure logo. Anyway, uh, just let's just use Microsoft. Not this one. Okay, so we do everything on Azure itself. We don't do everything. I mean, we run it from our local laptops, but actually everything is happening inside Azure cloud. You will create servers, you will connect to the servers. Okay, and all the servers are we are creating Linux servers which are created on Azure. And then after a while, first I will teach everything manually, how to go to Azure portal, how to log in your account, and how to create a Linux server. I will also teach Windows servers, but very little. We'll mostly focus on Linux servers. Then I will teach you automation on Terraform, how to create Terraform configuration. Also, I'll teach you Linux shell scripting. I'll also teach you how to manage your shell scripts, your Terraform code, your GitHub Actions, Docker, and everything in a even some programming. We'll take a Java build. We'll do a Maven build. Okay, we'll talk about Maven. So all these things we are going to talk in our course, right? So which are part of the development life cycle. And of course, before explaining each concept, I explain why is it used and what is the point of it. Okay, right. So if we have to put our course curriculum in a single slide, this is what it is. We're going to use operating system Linux. That's what we are going to be taught. I'm going to teach you. We're going to talk about Azure. I mean, of course, a lot of topics in Azure, don't worry. Then version control, then infrastructure as code using Terraform, CI/CD using GitHub Actions. So GitHub Actions, if you have not heard of it, it's a recent product from GitHub. But before that, we had something called as, I mean, even now Jenkins is there. So Jenkins used to do that stuff, but now we are using GitHub Actions because this is the most popular tool right now. Of course, there is Azure DevOps also, but we are not going into Azure DevOps because right today GitHub and Azure both are owned by Microsoft. So Microsoft itself is promoting GitHub a lot over Azure DevOps. Okay, so that's why we are focusing on GitHub Actions, which is very popular these days. Okay. So containers and container orchestration, because nowadays applications are moving from VMs to containers or Docker. If you don't understand the term containers, I mean it's Docker containers. So we are going to use container orchestration in the form of Kubernetes. So we will create a Kubernetes cluster on Azure, and I will show you how to log into a Kubernetes cluster, how to deploy your application, how to write Kubernetes manifests and everything. Okay, but again, I will caution you, Kubernetes is a very, very vast subject. We are going to touch like the basics, very, very important foundation, like 50%. Okay. Okay, so bonus. Apart from these, I will also go. I mean, I don't have a set of interview questions or anything because I don't believe in that kind of preparation. It's always a roadmap to failure. Don't rely on interview questions because the way interviews are conducted is different in technology. They don't go from a set of questions. Okay, they will look at your resume and based on what you have written, they will ask questions on that. At least that's what I do. That's what I have been asked in all the interviews, right? Not only towards the end, but for each topic, I'm going to discuss interview tips and notes and cheat sheets for all topics. Okay, so I have some notes written here and there, but I will all coordinate and give it to you. Don't worry. I have some PDFs, something written in GitHub, so I'll share all of them. I'll give you some resume tips. And again, don't ask me to prepare resumes for you. I can, uh, you know, give you, why is my numbering so off? Because I added the chat GPT and I forgot. Okay, and everyone is talking about chat GPT. What is it, right? It's a simple um, language model which will help you to get answers. So what I do is, I am using, as a DevOps engineer, I'm using ChatGPT in my everyday life. At least once in a day, I ask ChatGPT some question, some code. I ask it to write some code for me. So I will also tell you how you can use ChatGPT in your practice, and also later when you join as a DevOps engineer as well. Okay. So I'll show you how to use ChatGPT in our DevOps role. All right. Okay, I know many of you might have many questions, but before that, I will just complete this section. Okay. Um, so what do you need to be in this course? Like, people ask me these questions always, so that's why I have put this one. So you need a laptop or a desktop for sure. You cannot just manage with your phone because you need to practice them. And I would always request you to join from a laptop, because I don't know when you have a question, then I can ask you to share your laptop and I can show it to you then and there. Okay. And your laptop need not be super fancy, just like 4 GB RAM and a quad core would be fine. And what kind of subscriptions you need? You need Azure free tier subscription, which is free for 1 month. Um, so after the second month, you have to do something. You have to create a secondary account with a different email, different credit card, and go to someone's place. Of course, to create Azure free tier, you need a credit card. You will not be charged, but you will need a credit card. That's one thing. And you need a GitHub account, which is free again. You need a Docker Hub account, which is free again. You don't have to pay anything, no credit card, nothing. Of course, you can also create other user accounts like, let's say, Azure DevOps, which is part of Azure, so not a problem. And what software you need on your system? Ideally, I would say you should have administrator rights on your laptop. If it's your own laptop, no problem. But if it's a work laptop, I don't know how you can manage this, but you have to manage. So you would at least need these 4 or 5 softwares: Git, Azure CLI. Of course, you would also need Terraform, Git, Azure CLI, Docker, and VS Code. Of course, if you don't have them, you can run from a Azure VM, because first month it's free for you, so you can create a VM and run from it. But I would recommend to do this from your own laptop, which would be good. Particularly the VS Code software. VS Code is nothing but a code editor, a place where you can write code, which makes your life easy. Okay. And personally, a lot of people ask me, do I need to know programming? Do I need to know scripting and all that? If you already know programming, awesome. If you don't know, don't worry. We're going to learn. I mean, are we going to do a lot of coding? Yes, DevOps means there will be a lot of coding. It's not programming, it's scripting. You don't have to, and there is a lot of documentation, there's a lot of scripts already written. You just need to understand how it works, what is the syntax, what is a variable, how do you substitute that. Okay, I'm going to teach all that. First we are going to learn Azure CLI. I'm going to teach you Linux shell scripting, then I'm going to teach you um, Terraform. I'm going to teach you Kubernetes and YAML and all this stuff. Okay, yes, there will be a lot of coding, but you don't have to worry. You just need to copy and paste and understand how it works. Okay, I mean, I'm not saying everything is copy paste, but there's a lot of documentation, there's a lot everywhere written. You just need to copy that part and understand what it does and how you can modify that to your own requirement. Okay, so there will be coding, there will be more of keyboard than mouse, but I'm going to teach everything from scratch, so you will be fine. Okay. So personally, yeah, I'll come to your question. So personally, what is required of you is not any not any programming experience or anything, but active participations in the sessions, and of course, quality time for daily practice. When I say active participation, what I mean is, if you join from a phone every day, what is the point, right? You might be lying on a couch and you might not be interested. Okay, so I would want you to sit on your desk with a laptop, pen and paper if you are a pen and paper guy, or notepad on your laptop, and take notes. And quality time for daily practice. Our classes might be running for 1 hour or 1 hour 15 minutes every day, but after that also you need to practice whatever tasks I give you. Okay, yeah, I know I spoke a lot, so open for questions now.
Kiran,
Yeah,
this is Chandra here. So
yeah,
regarding the software installation part, like
yeah,
Terraform, Git, and everything,
yeah.
like you will be letting us know how to do the installation on our laptops, or else like can we go ahead now and do the installation part?
Yeah, you can go ahead and do it now, right? It's a very simple part. You just see the documentation and do it. Okay, but there might be some configuration. For example, after you install Docker, there are some commands I need to tell you how to run them. So yeah, for example, we will need a tool called as a Git Bash, which comes with Git software. It's like a command line, but it is coming from Git software. So I will teach those configurations later. Don't worry. I will teach you how to use Docker. For example, after you install Docker, how to command configure that and all that stuff. I'll teach them.
Yeah.
Don't worry. If you want to install, go ahead. No problem.
No, no. My request is like it's better to install the software in front of you when the session is going on. I mean, after the day, whatever the session, 1 hour session after you go, and then like we can put as like half an hour for the installation of softwares and to show like
Okay. To be very honest, that would be very difficult for me to look
I
into
know.
everyone's systems. But you can do it. I will show it on my laptop. Okay. I will show it on a Windows laptop. I mean, I use a Linux laptop, but for that session, I can create a Windows VM and I'll show it to you how to do it. Okay. You
Yeah,
have the
one pa-
recording with
one
you.
one one PC is enough to show.
Yeah. Yeah.
I mean,
Yeah.
you need not to show for all PCs. Like one PC, if you do it, so we'll follow the same steps and we'll create an VM and we'll install on the Linux machine. Yeah.
Absolutely. Absolutely. Yeah. You can do that. Yeah.
Okay.
You can.
And
Yeah.
yeah, I'm fine with it. So one more question I have is, see, GitHub is like Jenkins, and Git is a
Mm,
repository. Is it
No,
right?
no, no. GitHub is a source code management platform, meaning you can maintain your code in GitHub and give access to others. Let's say if you're 10 developers, you can create a
Mm-hmm.
repository and give access to all these 10 people to that repository. They can, after writing the code on their laptop, they can push it to GitHub. But how do they push it
Okay.
to GitHub? They don't push it by copying, pasting. They do that through a software called as Git. Okay. So Git is the original software that is, I mean, is a software created by Linus, and it's being used from so many. So GitHub is a platform. GitHub is not equivalent to Jenkins. Okay. GitHub is simply a source code management platform. Okay. But now GitHub can also do what Jenkins is doing through
Yeah, that's
GitHub.
what my question. Yeah, that's
Okay.
what my another question is like now what the GitHub is doing is in future they don't want to go with the Jenkins and the Microsoft is trying to do with the GitHub
Yep.
to do the deployments as well
Yes,
using the
exactly.
GitHub Actions. Yeah.
Yes,
So
exactly. So
Git is a tool like where we use like the commands like Git push
yes,
and all
yes.
these commands to
Yeah,
move the code to the GitHub repository.
perfect. Yes.
Yeah. Okay.
So GitHub Actions is the additional service that was recently added, recently meaning 5 years
Correct.
ago,
Correct. Correct. Yeah.
to do what Jenkins was doing. So earlier, if you have to do the stuff, you need GitHub. Also, you need Jenkins. Okay, and then
Correct.
for Jenkins, you need to create bunch of servers on your own, and you have to manage them. Okay, then maybe you need something like artifactories to store your tools, to store to store your binaries. Now everything is done by GitHub. So instead of Jenkins, you have Actions. Okay, instead of artifactory, you have what we call it as packages. So everything can be done in GitHub itself.
Yeah.
Okay, so this is repository, the CI/CD, and also the packaging is done by GitHub.
Yeah. Got it.
And Git can be used irrespective of whether you're using GitHub or GitLab or Azure Devops or Bitbucket. What else we have? Yeah, no matter what is your source code management platform, you can
Yeah.
still use
Maven
Git.
or anything. Maven or anything. Yeah.
Yeah, Maven is slightly different. It's not a source code repository, but anyway, you can still use Git for all of these things. Yeah, so we'll
Okay.
talk about Git and GitHub as well.
Yeah. Thank you. Thanks.
Okay, other questions? Anything about the course, about cloud, whatever? I think, I mean, Lakshmi Garu or someone will get back to you on the course timings and everything. Hmm. I mean, time will be 9 p.m. to 10 p.m. Unfortunately, that's the only slot available for me. 9 p.m. to 10 p.m.
9 p.m.
I'll
to 10
see.
p.m. is like what? Every day? Every day 9 p.m. to 10 p.m.
Monday through Friday. Monday through Friday. We might have classes on some Saturdays, but not all Saturdays.
Yeah. We can put like the lab sessions or something on Saturdays, right, Kiran? I mean, if you are
Uh,
okay. I mean, like,
yeah, I mean, I don't want see every class is a lab class for my class. I mean, at least
okay,
60% of my classes are lab classes because I do it on the class and show it to you how it is done.
okay, that sounds
Okay.
good. Sounds good to
Yeah.
me. Yep.
Except for the first 5 6 classes where I go mostly introductory, rest all will be hands on. I'm going to go into Azure portal, do the stuff. I'm not going through some PDFs or PowerPoints. I'm going through the portal, showing it to you right in front of your eyes how things are done in real time, and you will have to practice those same things. Okay, then we will
Sure.
go to a little advanced topics and we will do the scripting part. I will write the script right in front of your eyes from line 1 to whatever lines it takes, and I'll explain each of these concepts and you have to practice. That's the deal.
Thank you.
Yep, you're welcome.
So daily session will be the same time, 9 to 10 p.m. IST.
Yes, like I said, that's the only slot I'm available right now for the next 2 months.
Okay.
Yeah.
Yeah. So
I mean,
because
again, sometimes it might go up to 10, 15 as well, because based on the topic we are discussing or the based on the questions. I know it might be late for some of you, but yeah.
yeah, okay. So because we are connecting from US, it's
Yeah, yeah, right, Kiran. Yeah, that's what I also got confused.
So
Like
which
every
time
day,
zone?
9 to 10. No, we are on EST. I'm on EST time zone.
EST 9 a.m. is what, 7:30 a.m.?
no 9 p.m. is 11:30 here EST.
Oh, sorry, 11:30. Yeah, yeah.
Yeah,
8
Sorry,
a.m.
nine
Yeah.
and a half hours, right?
11:30
Yeah,
means
yeah.
like we are in the
We are in
office.
the office.
Yeah.
So
Okay, but I don't know. See, I can also take a little later. Earlier is impossible.
Yeah, because if it is
Yeah.
anything in the AM time, right? 6 a.m. like that, IST, it could
yeah,
be
that would
Mm,
be great. Yeah.
work for us. Yeah.
yeah, that's not possible right now for me. Yeah, I mean, yeah, unfortunately, that's the only time
Okay.
and of course, you have the WhatsApp number to reach out to, career IT folks. They will tell you what, I mean, if there is any alternative slot. But unfortunately, I cannot do any other times at this point in time.
Okay, gotcha. Yeah.
Yeah. I mean, I'm in a Central European time zone myself.
CST.
CET, yeah. Central
Okay.
European. Yeah.
Oh, okay. There's a Monday to Sunday, right? Every
Monday
week.
to Friday, Monday to Friday.
Okay.
Optionally, some Saturdays we might have classes.
Okay. Yeah. Thanks.
Welcome. Any other questions?
The request is like from my side, Kiran. Like I mean, if career IT and about you, if you have any other timings, that would be great for us. But yeah, we'll
So,
see how it goes.
okay, I don't know how many of you are there in the EST time zone, but if I take classes in, okay, I can't take, uh, let's say, 11:30 a.m., right?
No, for Indian time, IST morning time, if you take like morning time, like around 6 or 7 a.m.
Yeah,
IST,
yeah. See,
we
see,
are
even
good.
if I started, even if it started 7 a.m., right? That's what for me. In CET, it's going to be 3:30. So yeah, that's difficult. 3:30 a.m. in the morning, my family will kill me.
For whom? For whom?
For me, it's going to be 3:30 a.m. It's if it's 7 a.m.
No, no,
IST.
no, no. I'm talking about Indian time, 7 a.m.
Yeah, yeah. I'm in CET time right now. So 7 a.m. Indian Standard Time is. Oh, sorry, you're talking. Yeah, 7 a.m. time would be my what? 3:30 for me. 3:30 a.m.
Oh, you're not in India, Kiran?
No, I'm in Germany right now.
Oh, okay, okay.
Yeah, I came on an on-site deputation, so yeah, it's kind of a long-term project. Yeah, that's the challenge, guys. Okay, anyway, we'll stay in. I mean, you can stay in touch with Career IT, and if there's anyone else, or based on how I know this is particularly not very convenient for many of you. For me, it's the best time because I start 8 a.m. and 5 a.m., 5 p.m. CET. I'm done and I'm ready for the classes. But I know it's late for some of you. Okay, but besides besides the time, if you have any questions, yeah, go ahead. Not on the fees and other stuff that will be discussed by Career IT. Again, you can please make a note of, please make a note of the phone numbers right now, because if the chat ends, you might lose it. All right, if you do not have any questions, I really thank you for joining late on a Saturday, or midday in the US time zone. And yeah, thank you everyone.
Yeah,
Yeah,
thank you.
thanks. I hope you enjoy the weekend. Okay.
Yeah, you can also ping me on my Telegram. If you have any questions, we can talk about that.
Okay. Thank you so much.
Yeah, that's my ID on Telegram. Okay, then bye everyone. Thank you so much and have a good rest of the weekend.